Hi, so for today we're going to talk about inverse Laplace involving partial fractions. So please make sure that you have already watched my previous videos all about inverse Laplace, performing basic inverse Laplace before proceeding with these videos. And also make sure to recall your knowledge all about the partial fractions as we are going to apply it in our problem today. So for today's video, we have some problem involving partial fractions, inverse Laplace with partial fractions. So how do we solve the inverse Laplace of this f of s is equals to 86s over minus 78 all over quantity s plus 3 multiplied by quantity s minus 4 multiplied by quantity 5s minus 1. So as you can see, if we are going to recall our knowledge, okay, so this 86s minus 78 over s plus 3, s minus 4, then 5s minus 1. So as you can see, this has a distinct factors, distinct values of s. So this can be rewritten as a partial decomposition, okay, involving partial fractions, a over s plus 3. Since this is linear and distinct, so we have only a there, plus b. We have other denominator form, so we have s minus 4 plus c. This is still linear and distinct, so we have 5s minus 1. So we need to find the values of a, b, and c in order for us to get the Laplace transform. So if we are going to multiply this whole equation, by this, okay? So multiplying this whole equation, okay? We are going to multiply this whole equation by quantity s plus 3, quantity s minus 4 multiplied by quantity 5s minus 1. So what will happen? We have 86s minus 78 is equal to a, okay? So s plus 3 would be cancelled. So this will be s minus 4 then multiplied by 5s minus 1. So s plus 3 will not be included because it cancels the denominator. And plus, in this term, s minus 4 will be cancelled. So we have b multiplied by s plus 3 multiplied by 5s minus 1. And finally, for our c, 5s minus 1 here will be cancelled. So c will be multiplied by quantity s plus 3 times quantity s minus 4. And then, we're going to solve the values of a, b, and c by plugging some values of s. Okay, it's very easy for us to find that by assigning some values of s. Let me say if we are going to assign s at s is equal to negative 3, automatically this term, if we substitute negative 3 as s, so this would be 0. So this whole term multiplied by 0 will be 0. And the same for this one, because we have s plus 3, negative 3 plus 3 would be 0. C times 0, this whole term will become 0. So we can, but this term will not be 0. Okay? So if we multiply or if we use a value of s is equals to negative 3, we have 86, okay, multiplied by negative 3 minus 78 is now equal to a, okay, times negative 3 minus 4, okay, and then we have 5s. So that would be 5 times negative 3, negative 15, okay, negative 15, and then we have minus 1. Okay, solving for a, we can definitely solve for a. So we have this one, if we evaluate this would be negative 336. And this would be negative 7, negative 3 minus 4, negative 7 times negative 16. Negative 7 times negative 16 would be a positive 112a. And then we are going to solve for a. If we solve for a, that is negative 336 over 1112, which is actually equal to negative 3. So the value for our A is negative 3. And in order for us to find the other values, variable B and C, okay, we are going to again substitute values of S. So let's say we substitute S is equals negative 4, is equal to negative 4, or 4, I mean. So what will happen, looking at this equation, so S4 is S, so we have 4 minus 4 would be 0, this term would be 0, and this term also would be 0. This term will not be equal to 0. So we can find B. So what will happen? 86 times 4 minus 78, okay, would be is equal to 0, okay, plus we have B, okay, S plus 3 would be 7. 5 times S would be 20 minus 1, that's 19. Okay, and this would be 0. So again, we can also solve for B. So if we evaluate this, this would be 266 is equal to 19 times 7 is 133, if I'm not mistaken, B. So we can solve for B. B is equal to 266 divided by 133, and that is equal to 2. And lastly, if we want to find the value of C, okay, if we want to find the value of C, what will we substitute? Okay, we will substitute 1/5. Okay, so because we need this term A and B to be 0. And from the equation, if we let S as 1/5, 5 times 1/5 would be 1 minus 1 would be 0. Definitely, this term would be 0 and this term also would be 0. So, if we are going to substitute at S is equals to 1/5 is equal to 1/5, so we have 86 times 1 over 5, okay, from this equation, minus 78 is equal to, this is 0, and this is also 0. Then we have C, we have 1/5 plus 3, okay. Then we have 1/5 minus 4 for our values. Okay, so if we're going to compute, as we can see, we can compute C. Okay, if we evaluate this, this would be C, okay, times negative 304 over 25. So if we evaluate this, okay, that is equivalent to the operation of this. That should be negative 304 over 5. If we calculate for C, so we will divide both sides by negative 304/25. So what will happen? We have negative 305 over 4. And then we will be getting the reciprocal of this because we divided this. So what will happen? I mean, this should be 304, not 305. Okay, so what will happen here is that we have now 25 over negative 304. Oops, this is 5. Okay, negative 304 over 5. I'm so sorry, my mistake. Okay, so this would cancel. So this would leave C is equal to 25 over 5, which is actually 5. And now, if we are going to substitute the values of A, B, and C, so what will happen? This would look like this. This would be our f of s, or f of s, Laplace transform f of s, is now equal to negative 3 over s plus 3, as our value of A is negative 3. Okay, and plus B, which is 2, over S minus 4. And then for the value of C, that's 5 plus 5 over 5S minus 1. So here is our partial fraction decomposition. This is not the final answer yet. We need to get the inverse Laplace of this. So how do we get the inverse Laplace of that? Okay, so we have inverse Laplace, okay, for negative 3 over s plus 3. Then we have inverse Laplace for 2 over s minus 4. That is the property of inverse Laplace plus inverse Laplace of 5 over 5s minus 1. So again, we can factor out the constants. So we have negative 3 inverse Laplace of 1 over s plus 3 plus 2 inverse Laplace of 1 over s minus 4 plus 5 inverse Laplace of, we have 1 over, I can factor out 5 here. Okay, so if I factor out 5 here, that would be s minus 1 over 5. Okay, and I can factor out 1/5. Okay, if I factor out this 1/5 outside of the Laplace, this 5 would be cancelled. So what will happen? That becomes 5 over 5. That becomes 1. Okay, and we are left with the Laplace, inverse Laplace of this. So we can easily get the inverse Laplace by table. We have negative 3. Okay, e raised to negative 3t, since this is a plus. Then plus 2. This is e raised to negative 4t. I mean, that is 40 only because that's minus. Okay, that's 2 e raised to 40. And finally, we have plus, okay, because of this plus sign. Okay, we have e raised to 1/5 t, or t over 5. So this is our inverse Laplace of the given f of s. Okay, so let's proceed with another example. So for number 2 example. So for number 2, let me start with this. Find the inverse Laplace of the f of s, 2 minus 5s over s minus 6 quantity multiplied by s squared plus 11. So as you can see here, we have one distinct root and we have one quadratic. Okay, that is in the second degree. So we can decompose this into partial fraction, okay, by this form. So we have the first one, we have a distinct linear root. We have s minus a over s minus x. Plus, since this is a quadratic in the second degree, so we have bs plus c over s squared plus 1. If you may recall, this s is bx plus c in our algebra course. Okay, so since this is in the Laplace transform, the variable is now s. So how do we find the values a, b, and c? So we will use another method. So if we multiply, okay, if we multiply this whole equation by s minus 6 multiplied by s squared plus 11, so what will happen? We have 2 minus 5s is equal to, we have a times s squared plus 11, and then we have plus bs plus c, okay. This is now multiplied to s minus 6. So what will we do is to get or to simplify this term and this term, okay, and perform multiplication. So we have 2 minus 5s. This is distributive, so that would become as squared plus 11a. Okay, and notice in our second term, this bs plus c is in multiplication with s minus 6. So we have to perform the FOIL method. So what will happen? First, we have bs squared first. Outer, we have negative 6bs. We have inner, we have plus cs. And then last, we have minus 6c. So we are going to group. Okay, after this simplification, we are going to group terms, okay, that have the same degree. So we have 2 minus 5s is equal to as squared. Let me start with the squared. Then we have plus bs squared. Okay, so this is for the second degree, s squared. How about for those terms with s? Okay, so simply we have plus cs minus 6 bs. Okay, these two terms has s. And for those who don't have s, that's the constant. So we have plus 11a minus 6c. So what are we going to do is to factor out this s squared. We have a plus b. Then we can factor out s here plus s. That's c minus 6b. Then leave the constants as it is. Those terms that don't have any s. So from that we can conclude that from s squared, okay, we have the formula, okay, a plus b. If for our s, we have c minus 6b. Then we have for our constant term, we have 11a minus 6c. So, where is this three equation equal? So, what will happen here is that since this is s squared, on the other side of the equation, are there any s squared? Or is there any s squared on the other side of the equation? None. So, this would be equal to 0. So, for our second equation, okay, for our second equation, c minus 6b, so what will happen? Is there any s in the left side of the equation? Yes. And what's the constant of that s on the left side? That's negative 5. So, this would be equal to negative 5. Okay? And then, for our last equation, 11a minus 6c, do we have a constant on the left side? Yes, we have constant, that is 2. Okay, so just let me label this equation. So we have three equations. We have three equations, three unknown. Let me just label this as equation 1. Okay, you can label it as whatever you want. Based on my solution, I labeled this as 1, so I will not get confused. So we have equation 2, and then we have equation 3. So what will happen is that we are going to solve by substitution. Simple substitution to solve for A, B, and C. So if I'm going to manipulate this equation 2, so from equation 2, okay, I can get this in terms of, from equation 1, I mean, from equation 1, I can get that in terms of C. So C is now equal to 6b minus 5. That is from equation 1. So what will I do? I will plug in this equation, okay, equation 4, plug equation 4 to equation 2. Equation 2. So what will happen? 11a minus 6 times 6b minus 5 should be equal to 2. So, and what will happen? 11a minus 36b plus 30 is equal to 2. So, 11a minus 36b, 2 minus 30, that's negative 28. But, okay, but furthermore, I can substitute, okay, from equation 3, from our equation 3, we note that b is equal to negative a from equation 3, from this equation. Okay, b is equal to negative a. So what will happen? B is equal to negative a. I can substitute that. So what will happen? 11a minus 36 times, okay, we have negative a is equals to negative 28. So if we are going to solve that, that's 11a plus, okay, 36a is equal to negative 28. So 11a plus 36a, that's 47a equals to negative 28. And solving for a is negative 28 over 47. So this is our value for letter A. Okay, how about for letter B? Okay, so since, again, from our equation 3, since B is equals to negative A, so we got the value of A, so B should be negative of the negative 28 over 47. So that should be 28 over 47. And finally, we can get C from any of the formula here. So we have already 6b minus 5. So what will happen? We have 6 times the b, 28 over 47 minus 5. And the value of our c would be negative 67 over 47. So that's the value of our c. So therefore, our f of s in its partial decomposition fraction, okay, would be negative 28 over 47 over, okay, s minus 6. That's our value of a, plus, okay, from our decomposition, we have bs plus c. So our b is 28 over 47 s, okay, plus c. So plus minus, that should be negative 67 over 47 over, we have s squared plus 11. So get the Laplace transform. So as you can see here, they have the common factor 47 on the denominator. So this can be rewritten as the 47 here on the denominator. And then we can factor out 1 over 47. So if we factor out 1 over 47 for our equation to look clean, 1 over 47, that should be negative 28 over s minus 6, plus we have 28s minus 67 over s squared plus 11. Okay, so we have factor out 1 over 47. Take note that if we simplify this, 47 could be rewritten in the denominator. Okay, so here we factor out 1 over 47, and hence we can still simplify this so that we can get the inverse Laplace transform easily of this, as we can split this. So we have 28s over s squared plus 11 minus 67 over s squared plus 11. So if we get the inverse Laplace transform of this, so we have 1 over 47, then get the inverse Laplace of negative 28 s minus 6 plus 28s over s squared plus 11 minus 67 over s squared plus 11. So as you can see, 1 over 47, so inverse Laplace of this would be what? That is negative 28e raised to 60 by table. And of course, this one, we can factor out 28 outside of the inverse Laplace. So this must be 28 plus 28. And we are left with s over s squared plus 11. And by table, this is cosine, wherein this is our s squared, this is our a squared. So this would be s over s squared plus a squared. Our a squared is 11, so the value of a must be square root of 11. So we have cosine of 80. Our a is square root of 11t. Okay? And then, of course, minus, okay, I can factor out 67, okay? We have 1 over s squared plus 11. But take note, in evaluating the inverse Laplace of this, I can factor out what? I can factor out 67 inverse Laplace of 1 over s squared plus 11. But I can also what? I can also force this numerator again to be letter A. So because the inverse Laplace of sine 80 is a over s squared plus a squared. So I can multiply this both by square root of 11 over square root of 11. Okay? So I can factor out, so if I'm going to multiply this by square root of 11 over square root of 11, okay, I can factor out the denominator side square root of 11 to this. Okay, so that my inside function of the inverse Laplace could be now replaced by simply sine of square root of 11. So I will be having square root of 11 here, and this should be sine square root of a, which is the 11, square root of 11, t. Okay? So our value of a here again is square root of 11, hence we have square root of 11 here. So this is our answer for our inverse Laplace of the given question, f of s. Okay, let's go now to our last example. So for number 3, we need to find the inverse Laplace of our f of s, 25 over s cubed times s squared plus 4s plus 5. Okay, so we need to resolve this into partial fraction. So we have s squared plus 4s plus 5. So as you can see, we have repeating roots. So that would be a over s plus b over s squared, repeating roots, plus c over s cubed. Okay, and this term, we have a quadratic, but we can factor that. So we have ds plus e over s squared plus 4s plus 5. And our main goal again is to find the values of a, b, c, d, and e. So if we multiply this whole term by s cubed, s squared plus 4s plus 5, so what will happen? We have 25 is equal to a, okay, over a multiplied by s cubed with this and divided by s. So 1s of this would cancel, so that would be as squared, okay, multiplied by s cubed, s squared, s squared plus 4s plus 5. For the second term, s cubed over s squared, we have b times s, okay? B times s, because s cubed would be cancelled by s squared. And then we are left with s, which is this. And that is multiplied by s squared plus 4s plus 5. For the c term, the s cubed would cancel, so that would be c times s squared plus 4s plus 5. And for the last term, this entire thing would be cancelled, so ds plus e is now multiplied, okay, only to s cubed. And what are we going to do is, again, distribute and group again all the terms that have the same degree and formulate such equation and then solve for a, b, c, d, e. So we have 25, we have as raised to 4 by distributive property plus 4as cubed plus 5as squared. Then plus bs cubed plus 4bs squared plus 5bs. Then for here, we have plus cs squared plus 4cs plus 5c. And then finally, we have plus ds raised to 4 plus es cubed. If we group terms having the same degree, we have as raised to 4 plus ds raised to 4. Okay, this is raised to 4 plus 4as cubed plus bs cubed, this one here. And then we have plus es cubed. For our s squared, we have plus 5as squared. Then we have plus 4bs squared plus cs squared. Do we have any other? None. For simple s, we have s plus 5bs plus 4cs. Okay? So we don't have anything. So for our constant term that does not involve any s, we have plus 5c. Okay? So what are we going to do is we have 25 s raised to 4 a plus d plus s cubed, we factor out s cubed, 4a plus b on these two terms, and for these three terms. So this one also has s cubed plus e. So we have plus s squared, we have 5a plus 4b plus c. Okay, these three terms. Then finally we have s plus s, 5b plus 4c plus 5c. So we have 5 equations. So our first equation would be due to s raised to 4. So we have a plus b. Since we don't have any s raised to 4 here on the left side, that is equal to 0. So we have s cubed. We have 4a plus b plus e, and that is equal to 0 also. S squared, okay, we have 5a plus 4b plus c equal to 0 also because there is no any s here on the left side. The coefficient should be 0. So s, for our s, we have 5b plus 4c again is equal to 0. And for our constant, so we have 5c, and we have a constant term, so that is equivalent to 25. So therefore, our c from this equation is equal to 5. And from here, we can solve upward. Okay, from here, from the constant term, upward to our values. So substitute c on our this equation. Let me just rewrite it. So what will happen? So substitute 5 on our equation 4. So what will happen is that we have 5b plus 4 times 5 is equal to 0. So if we solve b, we will get negative 4. So we have negative 4 for our b. Then substitute b and c to our equation 3. So what will happen? We have 5a plus 4 times negative 4 plus 5 is equal to 0. If we solve for a, we are going to get 11 over 5. Okay? So negative 16 plus 5 is negative 11. So we have transpose 11 divided by 5. So we have a is equal to 11 over 5. Then substitute the values of a, b in our second equation. So we have 4 times 11 over 5 plus the b, which is negative 4 or minus 4, plus e is equal to 0. So we can get e by solving this equation, and turns out we get negative 24 over 5. Okay? And finally, we can get the value of d by substituting the equation to our first equation. So we have our a is 11 over 5 plus d is equal to 0. Therefore, d is equal to negative 11 over 5. So again, our given f of s is now equal to 11 over 5 over s. That's the value of a. Okay? Minus, because our value of b is 4, so minus 4 over s squared. Okay, and then we have plus 5, that's the value of c, over s cubed. Okay, so we have, let's make it a plus, abc ds. So our d is negative 11 over 5s. Okay, ds plus e, which is also negative 24 over 5, over, we have s squared plus 4s plus 5. So let me just rewrite the parentheses. Okay, so get the Laplace or the inverse Laplace transform. So this looks messy. Okay, we have 11 over 5, we have 11 over 5. What can we do is to simply factor out 1 over 5 from each of the terms. So what will happen is we have 1 over 5. So that would be 11 over s minus, since I factor out 1 over 5 here, so this should become 20 because 20 over 5 is still 4. So this is still equal to this. This is still equal if we multiply this 1/5 to this term. Okay? Then, so again, for our third term, so this should be 25 because if we multiply 1/5 here, this would become 5 over s cubed. And what will happen is that if I'm going to have this as the minus sign, convert this as the minus sign, so this would be a minus 11s. So this is minus, so this should be what? This should be plus 24, okay, over s squared plus 4s plus 5. Okay? I actually change this positive into minus. Okay? Into minus. So what will happen? This is would be negative 11s. Distribute this negative 11s, negative 24, which is equal to this. Okay? So now, we are now ready to get the Laplace transform. So, but first, we have to, this terms are easy to get the Laplace, this up to s cubed. But how about for this? So what are we going to do for this is the denominator, techniques from the inverse Laplace, the denominator, okay, this denominator is actually what? Okay, can be rewritten as s plus 2 squared plus 1. Okay, so we can rewrite the denominator as that. And then we have in the numerator, I can have 11 times s plus 2 minus 2. So this s plus 2 minus 2 is still equal to s. Okay? Plus, this would be plus 24. Okay? So that should be plus 24. Okay. So what will happen to that is this should be in parentheses because we already factor out minus sign. Okay? So this should be in parentheses. So along with the negative sign. So we make the numerator the same as the denominator because there is a Laplace table suited for that. So we have 1 over 5, okay? Just please bear with me. 11 over s minus 20 over s squared plus 25 over s cubed. So what will happen here? I can separate this into 2. So as you can see, if I'm going to multiply this negative, so that would be negative 11 times s plus 2. Okay. And if I'm going to distribute 11 times negative 2, that would be negative 22. Negative 22 plus 24, that is 2. And we multiply the negative sign, so this would be minus 2. So we have s plus 2 squared plus 1, okay, over s plus 2 squared plus 1. Okay? So, this is easily can be evaluated by tables. So, let's try 1/5. So, 11 over s, that is simply 11 because the Laplace transform of 1 over s is still any constant. And we have 11 here, so we have 11. So, minus 1 over s squared. So that should be 20t, the inverse Laplace of that. So factor out 20, Laplace, inverse Laplace of 1 over s squared, that is t. Okay? And then, for our third term, so the inverse Laplace of 25 over s cubed. So we can factor out 25 inverse Laplace. So we have 1 over s cubed. And we can multiply both the numerator and denominator by 2 factorial because we need to have a 2 factorial on the numerator of whatever inside the Laplace. So we have 25 over 2 factorial inverse Laplace of 2 factorial. So this should be 2 factorial over s cubed. So simply, we have plus 25 over 2 factorial is 2. And this is t squared. So t squared. Okay? Minus, okay, again, this is can be evaluated by table. So that would be 11, okay, e raised to negative 2t because of this. Then we have a value of a. So since we have s plus 2, that would be cosine of a, which is 1. Cosine of t. Okay? Cosine 80. So that is 1. And then we can also evaluate this by table. So since this is a constant, so that would be a sine. So minus 2 e raised to negative 2t sine of t. Okay? Quantity t or t, it's the same. Okay? So this should be our inverse Laplace transform for our final example. So I hope you learned so much for this video. If you learn, kindly subscribe to my channel and don't forget to leave a comment down below and have a thumbs up on this video. So thank you so much. For more tutorial videos, please don't forget again to check out my playlist in advanced engineering mathematics and also for different subjects such as physics, differential equations, and many more. So thank you so much for listening. God bless you. This is again Engineer Abat.